your co-workers. All right. Now, the electrical team. The electrical team, a lot of time, depending on the level that you are at in the organization, on your hands, on your knees, on your feet, in confined spaces, on ladders, scaffolding towers, scaffolding platforms, right? And all of these pose risks while working at work, right? And some of the main common causes of accidents when using these type of systems is really slips, trips, and falls, right? These are the most common type of accidents. They can occur while working, while walking, while playing, right? So how do we guard against these in the industry, right? This is where our engineering controls come into play and our administrative control and how we deploy them as electrical engineers, as electrical technicians, and as electrical technologists, right? Now, first rule, one of the most important rule, right? Any regulation that is put in place to protect you, you must obey and you must comply, right? If you do not, then you pose a high, you increase. Basically, when you look at risk management, if you don't comply, you run the risk, a high risk, right? The likelihood of any accidents occurring will increase drastically, right? Any way you want to put it, it will increase and you put yourself in danger. All right, so you need to follow these regulations. Whether it be a line that they put in place, do not pass this line, right? Stay within this line, right? It's a reason why it's put there. In some industries, for persons who are working, right, should know that these lines are relevant. You have things that you do not readily see, right, that will pose a problem to life, right, and your safety. So guys, please ensure that you pay attention to these that are put in place. Now, one of such laws is a statutory law. Is our statutory law, right? A statutory law is really acts of parliaments, right? These laws is something that you have to go to parliament, you have to vote on, right? And they have to pass it into being. Now, when it's passed into being, it basically become law and is punishable by penalties, right? Whether it be jail time, right? Whether it be a fine payment, right? These will always carry punishment, right? That's basically what a statutory regulation is. Now, there's also what is known as a non-statutory regulation, right? So if a statutory regulation is something that is voted by Parliament and carry penalties, then a non-statutory regulation is something that you must follow, right? It also carry penalties. For instance, if you have a facility to inspect, an inspector might fail it based on you not following a non-statutory or a code of practice, right? Now, so we need to look at, there are a few statutory regulations we want to look at that governs safety at work or safety in the workplace. One such regulation is the Health and Safety at Work Act. This act was actually introduced and passed in 1974. So it's one of our first acts, right? And this act enables us to develop further acts as it relates to safety in the workplace. So this act is known as an enabling act. So it's one of the first acts that was introduced to protect workers while carrying out their work activities, right? And it's classified as an enabling act, right? So this will not really specify if you are to do something or do that, but it is used to enable the other acts so that you can make amendments, right? Without this act, you would not be able to make amendments to some of the other acts that we'll be looking at, right? And it's basically to create a safe environment for everybody. The worker, right, which is the employee, the employer, right, and members of the public. A lot of time persons tend to not remember members of the public, but they are also a part, a stakeholder in your work activities. All right, just give me a few. Some persons I'm getting some prompts, so that's why you're hearing the prompt signal. All right. Our next regulation, statutory regulation that we'll be looking at is the electricity at work regulation. This really was introduced in 1989. I'll put the dates there for you to have an idea of how old these acts are, right, and how young they are, right, and the purpose of the Enabling Act. Now, the purpose of the Enabling Act, because the Enabling Act was so broad, right, they need to identify other acts, right, with the constant and developing use of electricity, right. We have in place the electricity at work regulation. Now, the electricity at work regulation really provides a framework for us to carry out certain activities in a certain manner while we are at work, right? This type of act is really administered by, in the United Kingdom, it's a health and safety executive, right? Our equivalent to this act would be our OUR, Office of Utility Regulation, and so on, right? So they have a responsibility for a number of the different enabling acts in Jamaica, right, to manage them, right? So they might have affiliating bodies that will create fines and so on, but these acts are really enforced and managed by the Office of Utility Regulation in Jamaica, right? Now, while doing these activities, right, there are certain things that we must do and in a certain manner. And these things and activities must be done in a way that it preserve life, protect you from danger and harm, and from missing limbs, right? Because danger is also present when you have limbs that can be missing due to work activities. Now, initially, the United Kingdom, because at one point 80% of the world population were using their codes of practice, and a lot of time you'll see regulations referring to the IEE regulation, which is a British standard for electrical, is a British standard 7671, right? So once you meet this regulation, a lot of time our local JS21, the National Electric Code in America are all developed based on the IEE regulations, right? They were developed and modified to fit the region or the environment or the state in which they are being used, all right? Now, our third regulation, this is the Electricity Safety, Quality, Continuity Regulation of 2002. Now, this regulation really affects the utility companies, right, such as JPS, the private power plant, in that they must maintain their quality of service and continuity of service. Now, in the case of an island-wide blackout, you notice that OUR, JPS would have to prepare a report, send to OUR, and OUR will do their external investigation to see if JPS is liable, right, or if was because of negligence, right? So this is basically what the electricity at work regulation does. In terms of quality of service, they have to maintain our frequency within parameters. They have to maintain our voltage levels within parameters, right? And of course, we don't want to have power outage, so they also have to ensure the continuity of service. Now, the fourth act that we want to look at is the management of the health and safety regulation. This was actually established in 1999, and as I say before, our local bodies or OUR. Now, the management regulation requires employers to have a first of all foremost a policy statement. So when you go to any industrial plant, you will see a policy statement being displayed. They have it sometimes on the gate. If you go to a construction site, you will see a policy statement on your gate again, right? It's visible for everybody to see, right? This act is what forces employers to put these systems in place. It forces employers to have a health and safety officer in most cases so that they put systems in place. It forces them to have safety procedures and practices in place, such as your evacuation plan, right? Your shutting down procedures. This act is what forces your employers to have these in place, right? And also forces them to do regular risk assessment while at work, right? So the maintainer, like for large industry, when you have the safety officers, they are in charge of constant review of the risk assessment portfolio. So they'll do probably a weekly or a monthly risk assessment. If they get a new equipment, they'll do a risk assessment, hazard risk assessment, and make recommendations to the management team. Right, so these acts are very important. The fifth act we want to look at is the provision and use of work equipment regulation, right? Now, this was established in 1999. Why? With the introduction of open market comes the rise of different suppliers and different manufacturer of equipment. So this regulation forces your employer, so like in large companies, it forces your employer to maintain some quality in the equipment, right, being used for work activities. Right, so it forces them to do so. So they can't go on. Why? Just to point out, they buy a piece of tool, right? And because of the tool being substandard, meaning it did not pass the necessary tests, right, to meet work standard, you will become injured, right? No, they are liable, right, to compensate you. It might be for the rest of your life. It might be for a short period of time, right? Or it might be a one-time payment, but they become liable if the fault is within the tool. Right? No, if the fault is how you use the tool, then and if you were trained to use the tool, because there are acts that they should actually teach you, right? They should actually train you, and that's the purpose of the training period. A lot of time it's on-the-job training because of our industry, right? 90% of the time it's on-the-job training, right? But you need to receive training in use of the different equipment, in the use of the different tools, right? So it forces them to buy quality tools and quality equipment to use on the plant. Now, the yes. All right, regulation number 6, this is the control of substances and hazardous for health and regulation. So this takes care of your toxic substances, right? Like your asbestos. Recently, we have an asbestos regulation, but before we have the asbestos regulation, it would fall under this regulation, but we have a recent regulation that takes care of asbestos. So for instance, moving to our sector of work now, when we talk about our fluorescent tubes that have mercury inside them, this regulation forces you to dispose of them properly, right? For persons who are unaware, fluorescent tubes should not be disposed of in your regular bin, right? Because if it breaks, then it runs the risk of contaminating the other waste, right, with mercury and can seep into the water table. Please mute your mics if you are not speaking. Anthony, Anthony, mute your mic. All right, sorry about that. What I'm saying, right, it forces you to dispose of certain material, even your PVC cement. It forces you to dispose of work-related activities in the electrical industry in a particular manner, right? If they are disposed of in a regular manner, then we run the risk of causing harm to persons, to ourselves, right, and members of the public, right? Now, employers under this regulation, it forces the employer to do a risk assessment. If they cannot remove the hazard, then they need to provide the necessary PPE. Right? Give me a minute, please. All right, sorry about that, guys. All right. So this regulation forces them to prepare, to provide the proper PPE to minimize the risk of danger to you, right? Now, this seventh regulation and last regulation we look at is the personal protective equipment, right? PPE. Everybody at this stage in final year should know what a PPE is. However, what I want to point out to you is that this regulation forces the employer to provide the necessary PPE required for specific work activities. So if you are working in an industrial setting, it forces the employer to provide you with the necessary footwear. It forces them to provide the proper headwear, head protection. If you are in a noisy environment where you have a lot of noise beyond the regular human hearing, right, it forces them to give you the necessary ear protection and the necessary eye protection, which is your safety goggles. If you're in an environment like the Kingston Wharf, they'll give you a high visibility vest, right, so that you can be easily seen from far off, right? So all of these are provided by the employer to protect you and the employee, and you, this regulation forces you as an employee to use the PPE that is issued to you, right? So even though it forces the employer to issue it to you, if you don't wear it, you become liable. So this regulation both protects the employer and the employee in its own right, right? So when you get a PPE, guys, wear them. You should also be taught how to wear them. So it's not to issue the PPE to you and not teach you how to wear them. They need to show you how to wear the PPE. They need to share with you how to maintain the PPE, right? They need to give you your correct size in the PPE. One, if you don't have your correct size, then it becomes a hazard. You have shoes and the shoe is big. You're going up a ladder, you're going on a platform, because the shoe is big, it trip you, you fall off, right? So you need to have your proper size PPE. You also need to clean your PPE, because a lot of persons, they have their work issued overall or clothing. They don't feel that they must carry it home and wash. They have it wearing for the entire month. They sweat in it. The sweat start to smell, and the smell become a hazard to your co-worker, right? So that in itself can become a hazard, right? So cleanliness, guys, cleaning your PPE should be critical, right? Checking your safety shoes. I know a lot of time persons don't check their safety shoes unless it start to drop off their feet, but you need to inspect it, right? You need to see if they have any chop right? Because it protects you from electric shock, it protects you from falling objects, right? It protects you from punctures, from things, sharp objects puncturing the soul. So you need to inspect them properly. With your safety gloves, you need to inspect them for broken section, tears, and so forth. Hard that, you need to check them for cracks and so on, right? So you need to maintain your PPE, guys. All right. So we are at our non-statutory regulation. Our non-statutory regulation, as I say, is really a code of practice. Now, one such thing to relate to you can be in your electrical installation, which you do done in engineering tools or your electrical workshop. Now, when you were at the workshop, the instructor or the technologist might say to you, you need to leave allowance in the box, approximately 5 to 6 inches of conductor cable inside the box. That's really a code of practice, right? When we say you need to strip the wire and twist clockwise, it's also a code of practice, right? So those are not so visible, but stuff that are visible might now be the mounted height of plugs and the mounted height of switches, right? So they're saying that once you follow these regulations, then you are within your statutory. So your non-statutory regulations are governed by your statutory regulations, right? They might not have jail time or fines or so forth, but when the inspector comes, there might be a motor you're installing and it should be installed in a particular way on pad, mount, and so forth, then the inspector can feel your job, right? They can feel inspection of the facility, right, and ask you to make these adjustments, right? So you have to actually resubmit. They give you another date, and then they come to the location, right? That's how it should be, but we know in Jamaica there are other ways of persons might tell you to get around that, right? All right. I identify 3 types of non-statutory regulation, which is our IEE regulation. This regulation is the national code for the United Kingdom, National Electric Code. You have the National Electric Code now, which is for your the American counterparts, right, and the Canadians, right? This code of practice actually is used for the electrical industry, right? We have our Jamaica Standard Electric Code, our JS21, which is our local code for electrical work, right? Whether it be industrial, commercial, or residential, right? So we need to understand these codes. If not, you're not going to have all the code in your head, right? And I tell people, listen, you can't know all of the code. Nobody will know all the code. They'll have a good idea, probably of 90%, 80%, but it's always best to consult your Bible, which is your code, right? Whether you think you know it or not, right? It's always good sometime. If it's something that you're not doing constantly, meaning on a daily or a weekly basis, then you need to refresh yourself. A lot of time, what they do is make amendment to these codes and publish them. So you need to go on the OUR website. They have the beauty about technology. We have a website where we can go and see where the codes or the practices are amended, right? So that's for our local regulation. All right, so this is where we mentioned this a while ago that the regulations relate to principally to the design, selection, erection, inspection, testing of electrical installation. Now, electrical installation is a big part of our discipline in the facilities area. When we talk about electrical facilities, we're talking about the framework, the electrical framework, right? We talk about how it is erected, the type of system, whether it be a flush system, whether it be a surface system, whether it be a conduit system, whether it be PVC conduit, whether it be galvanized, whether it be trunking, PVC, or galvanized, right? So these regulations will specify it based on the environment, right? It might be based on the economic condition of the customer. So these factors will drive the type of system that is installed in an electrical facility. Because if you have all the money you can spend, you can get the best system that looks the best aesthetically, right, and have the best protection, right? So it all comes down to finance in most cases. Now, statutory and non-statutory regulation, right? Non-statutory regulations and statutory regulations apply to permanent and temporary installation, right? For instance, of a temporary installation is the construction of a facility. So for instance, they want to build a substation. Well, I don't want to use substation because they're the same supplier. They want to build a bottling plant, right? So Red Stripe want to build a new bottling plant. They would apply for a temporary installation. Now, a temporary installation really runs for 90 days, right? And why it is classified as a temporary regulation is that how it is charged. Now, for whether it be a residential, commercial, or industrial, once it's a temporary installation, the rate will be the same. So you will be paying at rate 20. While our permanent installation, when you switch to permanent for your residential, it will be charged at rate 10, which is JPS billing procedures, right? So temporary installation, the term suggests, is temporary, right? And at the end of the day, you need to switch it to a permanent installation by sending in your inspection report, right? So you get your licensed electrician. If you're not licensed, they'll come, they'll inspect, they'll sign the job, they'll submit the job. The government electrical inspector will come, they'll inspect the facilities, they'll inspect the elevator system, the lighting system, the alarm system, all of these systems. Once it have an electrical installation involved, right, electrical works, they are going to inspect it and they are going to give a report, and then you can get your system permanently supplied, right? All right, so these regulations also apply to agricultural and horticultural premises, right? They also occur to caravans. We don't use them a lot out here. The best case of caravan that we have is our portable food trucks. A lot of time they have their own generator, but for those who don't have a generator, then they have to get a supply as a mobile supply, where they'll park at a particular spot every day and they are connected to the electric grid rather than using a generator, right? And we say the electrician's Bible, which is in our case, our electrical Bible is our JS21 for our local code. As I say, you can use the NEC out here. A lot of codes are the same, right? Truth and in fact, a lot of electrical persons locally are now using the NEC rather than the Jamaican standard code, right? So they tend to use the NEC, right? So what we are saying is that once your work meet these requirements, then they will comply with statutory regulation, and the inspector will issue a report that satisfies that all work is satisfied under the regulation. All right. Now, the health and safety responsibilities. Now, we need to look at the health and safety responsibilities in a little bit more detail. This relates to the employee and the employer, right? Because each person will have their part to play in safety in the workplace. In general terms, an employer must put adequate health and safety system in place, right? And and an employee must use all the safety systems and procedures, right? So the responsibility of the employer is to put them in place. The major responsibility of the employee is to use these systems, right? Now, let me just run through a few responsibilities. For the employer, right, these are a few. The employers must make the workplace safe and without risk to health, provide a health and safety policy statement if there are more than 5 employees. And I must tell you guys, being that we're talking about growing business, when you finish UTech and try to think about starting your own thing, if that's your thing, right? Don't make things hold you back, right? Try to start it, try to put some time into your business and grow your business, right? A lot of time we need persons in the sectors that are degree qualified as well as know-how qualified, meaning have the practical skill, have the paperwork, right? When you have the two, right, you get jobs with a regular electrician guys. Because we're not talking about electricians though, right? We're talking about electrical engineering. No, electrical engineering, yes, it involves a lot of installation, but it also involves a lot of other technical stuff. For instance, like generator maintenance, generator installation, right? Control circuit installation. A lot of time, the regular electrician out there just learn something from him friend, right? And a lot of time they just can set up the simple control circuit for probably a water system. But once the customer asks a new technology, new modification, then they are lost, right? If you don't practice these things and you just learn them, and I must say that from personal experience because the first time I did a solar system, right? It was so much different. Yes, we know the calculation and all, but in actually installing the solar system is you don't learn anything like that at UTech, right? You learn to do all the calculation, but to implement these now, right, is where the know-how come in, trial and error come in, right? And this is why we are providing you guys with a degree so that you can read, right, and do the necessary work. For instance, a lot of guys out here where they are using what is known now as a hybrid um, inverter, right? Now, a hybrid inverter really takes multiple input and you program it to switch in inputs based on what you set as priority loads, right? Now, it's not a new technology. It's something that was being used in other developed countries for a long period of time, but now it has gained traction in Jamaica where persons want to have their generator, they want to have their JPS, they want to have wind energy, they want to have their solar energy, right? And they want all of this to be tied in and supplied by one system, right? And this is where your hybrid inverter comes into place. Very useful. We have solar drive, right? A solar drive basically is an incorporation of power electronics technology, right? These are stuff that are out there on the market. They are being utilized, right? Now in Jamaica, they are as new technology, but they are not new technology. They have been used for so long, but because of our renewed interest and in solar and renewable energy, then these become very important to our region, right? All right, back to the slide. Now, provide adequate information. So the employer must provide adequate information, instruction, and training. Remember, we said this before, and supervision. So And this is why supervisors are in place in workplace. The supervisor's job is to ensure that the health and safety procedures, right, the work procedures are being carried out in the way that they should, right? This will enhance health and safety of the employees while doing work activities. Now, the employer must provide any protective clothing. We talk about that required for the Health and Safety Act. Report certain injuries, diseases, and dangerous occurrence. I want to stress on the dangerous occurrence because I know a lot of time, what's a dangerous occurrence? Let me clarify it for you. A dangerous occurrence is basically a near miss, right? The saw nearly take off your finger, right? You nearly walk into the machine. It might be because of how the machine is located. It might be how the walkway is lined, right? So it's their duty as an employee to report near miss so that action can be taken. So a near miss for me today might not be a near miss for you tomorrow, right? Provide adequate first aid facility, provide adequate welfare of his facility, right? So they must provide, and a lot of time, person believe in only large companies providing health care, right, in terms of a health card and this and to facilitate and promote good health. But in today's society, they realize that employee wellness is an important part of any industry. Because if your employee is mentally healthy, physically healthy, then they will realize that they'll do the job much better, much safer, right? And you'll get more out of it, right? So it has come to a lot in industries now, in work situation, workplaces, they're implementing a lot of health and safety program. The Surgical Run is one such thing, and all of these different charity events are really wellness activities, right? No. So these are still a number. We can just run through a few, but you can read them when you get the PowerPoint slide in much more detail, right? Undertake precaution against fire, provide adequate means of escape, and the means of fighting a fire. So you must have the safety signs them in place, your exit signs, you must have your warning notices, right? You must put fire extinguisher, the proper fire extinguisher, not just go and buy a fire extinguisher. You need to identify the class of fire that you might have, right, and buy the correct fire extinguisher. It might be that you need to install a fire suppression system and so on. When the fire agency come, that's the National Fire Brigade, they have the responsibility of inspecting the building fire safety, right? There should be the entrances based on the capacity must be a certain size. So like these things, when the architects are designing facilities, in the design phase, they have to take these into consideration. The size of the entrance door, the size of the exit door, how many exit door, the fire escape route, if it's a multi-story building, if it have an external fire escape, if the external fire escape have a ladder system, all of these they have to take in consideration when designing these systems, right, for facilities. Ensure that the plant, equipment, and machinery are safe. That is another employer duty, right? And ensure that procedures of work are put in place and followed. For instance, when you were doing your mechanical workshop, they probably show you how to start up the lathe and how to shut down the lathe, right? These are procedures that you should follow to enhance safety. Ensure that articles and substances are moved, so you don't put things in the way, you don't put boxes in the way, you don't leave your vehicle parked in the way, right? All of these are moved, are in their respective location, so as not to cause tripping. Remember, we said tripping is one of the most common type of faults, right? And slips. If you don't clean up after yourself, then it might cause a trip. If you have a spill, You might have an oil spill while changing, servicing a generator, right, and so on. So you might be servicing a piece of tool. You might work at Delta, you're servicing a tool, and you have an oil spill, right? You create a hazard. So you need to remove the hazard. A hazard like that can be removed. You don't need to have engineering control, right? All you need to do is just do your proper housekeeping. Keep those fumes and noise under control, right? A lot of time this, if you realize in the construction industry now, they tend to use the mesh, the safety mesh around the buildings when doing construction, because these construction taking place in the middle of the city and in the middle of residential areas where persons live, right? So they have to take the precaution as to reduce the dust that is dispersed to the environment. All right, an employee, right? The employee must take reasonable care of their own health and safety, and that of others who might be affected by what they do, right? So we're talking about colleagues, we're talking about members of the public, right? If you can't trust a colleague, you can't work with him, right? It don't make sense. You have to develop a trust, right? You have to trust that person. Why? Person can kill you. You're working on a piece of equipment, right? You might trust an employee, your co-worker, to say de-energize and lock out the electrical supply, which you should actually be checking and testing. But say you make their checks, right? And that person, remember that dead man can't tell no tale, you know, right? When you become electrocuted from a live circuit, right, that was energized after the fact, right, then him probably get a scotch-free, right? And this is why we have to trust each other. And also, if you don't trust the person, you need to make your safety checks each and every time, right? But luckily, there are systems in place for a situation like that, because each person that is part of the electrical team that is working on a particular equipment should have a lockout for the equipment, right? And when everybody remove their lockout, then it can be energized, right? But a lot of time we don't follow these procedures. Normally add time to the work activity, and we want to do these work activities in the shortest possible time. Cooperate with your employer on all matters relating to health and safety, right? Not interfere with or misuse anything provided for health and safety, such as your PPE and your work equipment and your tool. Report any identified health and safety problems. So these are like your dangerous occurrence. So you must report them to a work supervisor, manager, or another employer. Employee, sometimes you can say to your employee, if you don't feel comfortable saying it to management, and that person is an outspoken person, you can say it to them. It might be a union representative, right? You say it to them and they can bring it to the attention of the employer. All right, what is an hazard, right? So being that we talk about all these health and safety procedures and practices, now we need to identify what are the hazards, right? And we say a hazard is really anything, whether it be a work activity, whether it be an equipment, right, that can cause potential harm, right, to either the equipment, people, right, then it is identified as a hazard, right? So a hazard is something with the potential to cause harm to people or equipment, right? For example, chemicals, electricity, or working above ground. I'll put some of the most common one, right? Working above ground in itself is an hazard, right? And in our type line of work, once you are working above ground, then the hazard is potentially doubled, right? No, typical work activities that can cause that are potential hazardous, right? Receiving materials which carries a risk or a hazard of lifting and carrying. If you are lifting incorrectly and carrying incorrectly, that in itself becomes a hazard, right? So if you are lifting, you lift from your knees and keep your back straight. If you are carrying, you do not stack objects and to block your line of sight, right? Stacking and storing. You talk about falling objects, because when we are stacking objects, we are supposed to stack with the heaviest object at the base, and we start going up, or the widest object at the base and we start going up, right? So it's an activity that you have to adjust to. Movement of people, we talk about slip, trips and fall. Building maintenance, working at heights or in confined space. So you might be a maintenance personnel in a facility, right? We talk about height and we're talking about confined spaces. Movement of vehicles such as the wharf, we talk about collision. So what they do, they put all of the roads to be a one-way, right? So when there's no reversing, you continue onward, and circle and park, right? So this is one, even on the road, the purpose of having a one-way is to prevent the collision of vehicle, to reduce the collision of vehicle, right? Or confusion while using the road, right? So they put a one-way notice in place or a sign. Now, a risk. So we say the hazard is the possibility, right, to cause harm, while risk now is the actual harm being done, right? So a risk is a possibility of harm actually being done, right? It is a high, low, or medium risk. So you have to classify the risk. Who is at risk, right? It can be like office staff, electrician, members of the public, right? And you need to ensure that adequate control is in place, right? Whether it be engineering control or it be administrative control, right? And again, administrative paperwork, admin, right? While engineering systems that you put in place, guards that you put in place, barriers, right? All of these are engineering control. Safety at work. Methods used to prevent hazards, right? We talk about warning notices. We're going to explain that in a bit, in a few minutes, right? We talk about insulating live electrical parts, and we talk about barriers, right? So all of these are ways that you can prevent electrical hazards or minimize electrical hazards, right? Now, warning notices. These are basically safety signs that are displayed in a working environment, right? They are used to inform workers of the rules, right? Inform workers of regulation, right? That are actually relevant to a section, right? So in one section, for instance, I can use Petrodrum. If you work in an administrative building, you cannot go on the plant. You are not authorized to go on the plant, right? Some administrative staff at certain level are authorized to be on the plant, but some workers are not authorized to go on the plant. While the plant personnel are authorized to go in the administrative building, they are probably not authorized to go in different sections of the plant. They might be confined probably to the warehouse, right? And so on. So this is what we talk about sections, and they will have their own rules and policies in place. They inform and give warning of possible danger, and these signs must be obeyed, right? There are basically 4 types of safety signs, right? 3 of them follow the traffic light that is on the road, while 1 is another color. Now, when we talk about safety signs, right, the different type of safety signs, let me show you what we're talking about. We are talking about warning signs. We are talking about advisory signs. We are talking about mandatory signs. And we are talking about prohibition signs, right? So warning signs are your yellow signs. Advisory signs are your green signs, Mandatory sign are your blue signs, and prohibition signs are your red signs, right? What all of these mean? Let us get on with it. No, so a warning sign gives safe information. They give safety information. These are triangular yellow signs with a black border and a symbol as shown. Right, so I'll show you some example. Danger, high voltage. Warning, guard dogs. Danger, men are working overhead, so they might be working an overhead line. Danger, radiation, right? So they give you a safe warning, right? And they are displayed in yellow. So they make it bright, same like the stoplight. The stoplight yellow sign or amber warn you to proceed carefully because red is about to appear, right? We have our green sign. So these give safety information again, but these give you in a way that you are to do these, right? So they are basically green signs with white borders and they give safety information. Now, for example, fire exit, right? You see a person running into an exit, emergency stop for a machine. And one thing to point out before I go any further is that regulation, first time, we just have the exit sign and you see the word exit. But because we are in a day and age where we have persons that are unable to read same way, right? The new regulation forces you to put a symbol on your safety sign, right? And this is done for persons who are unable to read. You might unable to read Spanish and the sign is in Spanish. You might unable to read English and the sign is in English. So it gives you a particular suggestion. For instance, the man running to the arrow, when the arrow pointing, so you tell him to go this way. You tell you to push this button on the machine for stop, right? So you will push the button on the machine, right? So these are basically mandatory now to have visual effect on the safety signs. We have our mandatory sign. These are must-do signs. So when you go to the lab at UTech, you will see these signs and tell you that you must wear your lab coat, right? You must wear your eye protection when using the lathe. You must wear your eye protection when you are using the grinding machine and the drill. You must use your lab coat while in the electrical lab, the electronics lab, or the workshop, right? You need to wear them. So for instance, telling you that you must wear an ear protection for this machine. It might be placed on a machine to tell you that once you're operating, you need to have your ear protection. Once you're on the plant, you must have your safety or head protection, right? And you must have your foot protection. Now, prohibition sign. These are must not do sign. Do not smoke. Do not cross the red light when you go to the stop light because it will cause a collision, right? So you stop at the red light and you go on your green. The green is safe to proceed, but you still need to observe and do a quick assessment before you proceed. Same way in the workplace. You have your must not do sign, you have your advisory sign. You still need to observe, even though it's a green sign, right? And ensure that it is safe to proceed, right? No use of, do not use ladder, right? It might be in a case where the ladder is not sufficient and you need a better standing or access equipment. No entry a lot of time, right? It might be that, for instance, you have a tire shredding device on the road, it tells you no entry, do not enter. It might be a one-way road, do not enter, right? The room might be unsafe due to magnetic field. It might be a high voltage testing lab, so it says do not enter, right? And so on. Do not smoke because this environment might be flammable, right, or explosive. All right, so we talk about insulating. So we finish with signs now. We'll talk about insulating live electrical parts, right? So I will show you some ways of insulating. So the one on your far right, which is the knockout and the panel being exposed, that's a no-no, right? So you need to take care of that as an electrical person, right? And different methods of making insulating electrical parts might be your twist connector, your electrical tape, your PVC electrical tape, might be to protect yourself in your PPE as a person is on this diagram, right? And so on. Now, just give me a minute. The slide is not changing. I want to know why. All right, so it's changing now. All right, segregation of different work activities, right? So these are your barriers, right? So your barriers play a critical part in our electrical field, in the construction field, right? In any work activity, barriers play a very important part. Once it's a technical type work, it's one of the most useful forms of isolating work activities, right? Segregation of work from members of the public, for instance, your construction site, your substation might have a fence around it, which is really posed as a barrier for persons not being able to access. Your construction site, your facility might have a perimeter fence, and all of these are basically barriers, things put in place to protect members of the public, right? And only enables authorized personnel to access these areas. Prevention of fall from heights above 2 meters, right? So barrier can do that as well. All right, our security tape. So we're talking about security tape, which we know is our caution tape or danger tape. We talk about barrier materials, can be like timber, metal, plastic, anything that can actually be a barrier material. You might have a panel. Say for instance, you are at your workplace and you see a loose wire, a wire becomes loose. You can simply just draw the X in front of the wire and it becomes a barrier, right? Now, how effective it is another thing, because a person just see a DEX, they'll tend to want to move the DEX. And this is why we have a lot of these are used with other methods. For instance, barriers are normally used with security tape or warning lights, right? Or warning signs or warning symbols, right? So we don't normally use them by themselves because of the nature of what we are protecting, all right? Now, whenever you work with power tools, right? So we're talking about electrical danger again in facilities. When we work in power tools, right, an electrical circuit, there's a risk of electrical hazard, right? Now, the main hazard we talk about when we're talking about electricity is electric shock. Resulting from electric shock, we can have electrocution, burns, falls, right? Fall come into place if you are working on a ladder, right? Now, so electrical workers basically must pay attention to electrical hazard. This is one of your main job function, and you need to pay attention to this hazard in particular compared to other workers doing activities, right? A lot of the time, 100% of the time, you, the electrical worker, the electrical team would be the one to protect other teams from electrical danger, right? By either deploying one of the methods that we talked about before, right? Or all of the methods that we talked about before in reducing or preventing electrical hazards. Now, what primarily causes electrocution? Contact with overhead power lines, right? This is for our utility workers, right? Contact with live circuit in panels. A lot of the time when we are working on panels in a facility, it is very difficult to shut power down the facility. So we need to ensure that we wear our proper PPE when we are working in live panels, including your gloves, which will reduce the risk of electrical shock. If you realize he's wearing electrical insulated gloves, that's rubber gloves, and he has the mechanical protection for the gloves, right? Because the electrical glove is a rubber glove, can be punctured from screws, even the meter lead. It has to have a mechanical protection, which is our regular, is the cloth glove that you see over the rubber gloves. He has his helmet, he has his coat on, work coat or jacket, right, to prevent flash burns from electrical flash arc. And he has his glasses on, which provide from flash arc or protect from flash arc, right, and his face protection and neck protection, right? So he's well suited. Most likely he's working in a high voltage panel, right? So probably up to 600 volts, 440 volts and so forth, and he take necessary precautions, right? As engineers, we need to take these precautions, right? Because we run the risk of electrocution. And for persons who don't know, electrocution means death, right? That's what electrocution means. So when you tell somebody, say somebody get electrocuted, we're talking about death. If you're talking about somebody getting shocked, well, this is not a shock that did not result in electrocution. So another thing that can cause electrocution is poorly maintained tools and cords, right? Lightning strike, we realized that that was in last year when persons playing match were electrocuted on a field. Persons climbing tree while rain is falling pose a risk of lightning strike and becoming electrocuted, right? So we tend not to play with electricity, guys. All right, 4 main types of electrical injuries, right? So we look at the different types. We talk about electric shock. We talk about burns from flash, electrical flash or shorts, right? We talk about falls or fall due to contact with electricity. So you might be on a ladder, you might be on a rooftop. And for persons who don't know or never feel one before, when you get the right electrical shock, it tend to lick you, it push you away. I should not say hit, it push you away from where you are, and you tend to pull away, and this can cause you to fall, right? And then electrocution, which is death. Now, working with electricity at height, now I will talk about it again, be aware, maintain safe working distance, that is from the edge of the building. If not, you need to ensure that you are wearing your safety harness, right? And that is why the JPS line workers or pole workers belt off, they call it belt off when they ascend the poles, climb the poles to where they want to work, then you belt off, and then you start your work, right? Electrical shock. So breaking it down in more detail. When a current passing through the body is when we receive an electrical shock. Person should be aware of that as electrical engineers, right? We're all aware of that. But how do we actually receive an electrical shock now is when we come in contact with a live or ground or live on live, right? Or live on neutral. Now, coming in contact with any of these manner, you will receive an electric shock, and the severity of that shock will be determined by a number of situations, right? Now, first of all, what you will experience when you receive an electric shock, you will experience the threshold of perception. That is where you just feel a tingling. So if a person's who ever hit their hand up or them elbow on something before, and you feel a little tingle, that little tingle is you actually receiving an electric shock, right? So that little tingle is you actually jerking out or you receive the threshold of perception. Now, further, a 10 milliamp to 15 milliamp current, which is very small. As engineers, we know that, right? Will cause a tightening of the muscle. This is when your muscles start to contract, and it's become very difficult for you to let go of the cable. You might be holding a cable or any device that you're receiving the shock from, right? Further extension of the tightening of the muscle. So after a period of time duration or the severity of the shock, you will tend to reach this region where you have 25 to 30 milliamp passing through your body. And then above that now, so at 50 milliamp, we're talking about the final death, right? So at this point, we are saying that 50 milliamp is enough to cause electrocution in a human body, right? Very critical figures. Now, the shock severity. Now, person might tell us, if you're receiving a shock, you must call another person, and then the shock becomes less, right? I don't know. It's true to some extent because it increases the resistance, right? But that person need to be in contact also with ground or neutral or something like that, right? Or another life part. Now, the severity of the shock is dependent on the part of the current through the body. Now, if the current passes through the body, through the heart, that's where electrocution will occur the fastest, right? The amount of current flowing through the body will also determine the severity of the shock and the duration of the shock current through the body, right? So the amount of current passing through the body will be determined by the mass. You hear them say, like, if you're skinny, right, or you're a slim person, then the shock become more severe. If you have more body mass, your resistance is higher, so the current passing through your body is less, right? So I put a note here, low voltage does not mean, right, low hazard, right? Very critical. Now, also, all of these are affected by moisture in the body. So if you were sweating while doing the activity, all of them are double, right? All of these things that we talk about that depend on this, will determine the severity of the shock, will double, right? Some of them even triple if you are wet, right? So it's very critical when you are doing electrical work to stay dry. So if you are a person that sweat a lot, you need to wear your safety gloves, right? Electrical burn. I will show you somebody that received a burn from an electrical shock. You realize that it looked like rubber, right? So persons, I was working with somebody the other day at work, and the person was saying that he received a shock from a solar system. We were doing some solar installation, right? And he was saying that he received a shock, and oh, the guys who are working with him, and them, they want to kill him. So he must say, boy, and actually these starts smell like pork, right? When you jerk pork, right? So he's trying to say to us then that the severity of the burn from the DC voltage, for persons who don't know, DC as shock from electric for direct current is more critical than the alternating current guys, right? A shock from the DC, high voltage DC will cause serious harm to that of the AC of the same voltage level, right? All right, so we're saying burns suffered in electrical accident are of three basic types, right? Electrical burn, current burns, arc burns that are from arc flash, and thermal contact burn that is from overheating, right? So for instance, you have an insulation that is overheating, right? When you touch it, that is what we call our thermal contact, right? An arc burn is when we have a short circuit, a flash, while the electrical current burn is our regular electric shock, right? electrical current burn. In electrical current burns, tissues, basically whether skin level or external, right? Your tissues are damaged, right? Because the body is unable to dissipate the heat from the current overflow, right? For instance, when I was doing first aid or first aid training, when they say you will receive a burn, right, and they tell you that you need to flush it with water, with regular running water, right, the faster you can remove the heat is the better it is for the area where you receive the burn, right? So it's because of our body unable to dissipate that heat, right? That is why we receive electrical burn. Arc flash burn, guys. So arc flash burn again occurs from very high temperature, right? So huh?
You said that the faster you do what with the burn?
Remove the heat. So that's why they always tell you to flush it under water, running water, because the running water takes away the heat. Once I can remove the heat fast enough, and it do work, guys. Because a couple years ago, my wife get burned in the kitchen, and that was after doing my first aid certification. Right away, I tell her to put, we just put it under the running water in the pipe, and then start run that on it, and then start pour ice water on it to remove the heat as fast as possible. And it never burn, it never have any water bubble, it never discolored. By the end of the day, not even realize that a burn was there, right? So the faster you can remove the heat from the burn, right, is the better it is in terms of a fire. But in terms of electrical burn now, by the time you to get the burn, if you ever get a burn from a solder iron or electrical wire, by the time you touch it, you start to feel, you actually feel the indentation of the wire, the cable, in your fingertips, if it's your fingertip. Most of the time when it's going to be your fingertip or your hand niggle, right? You're going to start to feel the indentation. That type of burn is very difficult to remove the heat because the skin already damaged. From you touch it, it's like an instant damage to the skin and the cells, all right?
Okay.
All right, so arc flash burns are caused by electric arcs, which we said before, right? And similar heat burns for high temperature sources. Now, what this is basically saying is that the arc flash burn, like a 3rd-degree burn, for instance, a building that is totally on fire, by the time help is to arrive from the high flames, and we say heat can actually burn, right? The heat from a source of energy like that will cause damage, whether you are close or in contact with the fire. So we are saying that an arc flash will, you will receive an instant type burn. It's very difficult to remove the heat from that as well. And this is why electrical burns are so critical, right? Compared to that of the fire. The fire will take an instantaneous exposure to fire or hot substances, depending on the temperature too, because if it's really like super hot, right, not super steam but super hot, then it will cause instant damage to the tissue, right? But if it's of moderately high temperature, then you can remove the heat from fire burn. But electrical burns, very difficult. Thermal contact burn, we talked about this already, really proximity to the skin and so forth, right, from heat source. All right, electrical hazards continuing, we're going to look at a different hazards from here, some different hazards, right? One thing to point out here, right, the hazard is the cover being removed and the wires hanging and wires are loose, right? So there are a number of hazards in place here, right? So something like that, this will happen over a period of time. The cover might be removed and not replaced, it might be broken. The wires start to come off the structure, all of this. These type of hazards are easily rectified if you pay attention to them. So not all the time persons tend to pay attention to hazards until they cause damage to persons or damage to equipment. All right, and this is the reason why we need to have, and the government is looking at passing the safety policies that each organization and business must have a safety personnel in place to do these regular inspections, right? It's very critical. All right, so we talk about control methods, right? Isolate electrical parts, right? Use guards or barriers, replace cupboards, right? So that for this type of hazard that we're talking about use of guard or barriers. This is one way of preventing this, because if we were to cordon off the area here, then it will prevent persons from reaching the box on the terminals, right? If we replace the cover, then they are unable to touch the exposed cables, all right? So control method, right? For this, we need to isolate, right? You realize that on your left, where you see multiple cables coming out of that knockout, that's a no-no, right? This type of job or inspector will definitely fail. So if you are in your facility and see something like this, right, it was probably done after the inspection, right? But as somebody that knows what you are supposed to do, then you have enough knockout on the box that you can remove the cable, put your connector, whether it be a bonding nipple or it may be a compression conductor, right, connector, and remove them, right? So you should have one cable in this sense, sheeted cable passing through a knockout, right? So not multiple cables. On your right, you have an open knockout. On the OSHA standard, this need to be repaired, right? So you need to put a blank in place, right, to cover the knockout. You realize this must be an American diagram because the person put a duct tape, and then the duct tapes tend to start to fall off, right? So I don't want to say that, but some persons are famous for using duct tape to try to solve everything, right? So this is basically a no-no under the electrical codes of practice. All right. Now, the purpose of you having the compression connector or the bonding nipple is actually to provide mechanical protection, right? So for one, this particular diagram that you are seeing on your left, somebody is able to go there and pull the cables and possibly pull them right out of the box, right? So there's no protection provided for the terminals or the termination or the cables, all right? Yes.
What you recommend that should have gone where the hole is at?
Well,
the hole. So what
that's where the knockout is?
Yeah.
All right. Two things. Locally, I don't know if it's available, right? But you have, in some countries, we do have blanks that can fill out this, right? In other cases, then you would have to be creative, right? In my instance, I normally just cut a piece of sheet metal, right? For me, personally, I cut a piece of sheet metal and rivet it into place.
Sir, what if you use so it is not, you recommend to use a flex conduit from there? If for some reason
Which one you're talking? The one on your left or the diagram on your right?
The one on your right, left, sorry, left.
The one on the left, yes, you can use a flex conduit. But we are saying that if you are using the flex conduit, you have to size it properly to have the allowable space factor to have the 3 cables in there, right? But if I'm using a flex conduit, I would not want to use sheeted cable, I would just use single core cable. Don't
That
think.
is true. Yes, yes, sir. That is true.
Right, so again, it comes down to use of equipment, right, and materials, right? Because obviously, as I said before, in a situation like this, most of the time it was one cable, right, and then they knock out a bigger knockout, put the connector there, the coupling, the ends, pass another cable, then somebody pass another cable through it, and then it becomes three, right? So rather than just go buy a regular 2.5, because this look like a 2.5 cable, right? It might be 1.5. Well, rather than to go and buy your bonding nipple or your compression connectors, they tend to use what is there. All right. But one thing again, guys, as an electrical person, you should have, listen, it's good to have tool. This as an electrical person, once you practice in the field, once you practice even at home, basic home, you're going to want to have tools, right? Because you want to do the job sometime, right? And you do the job and you feel nice that you accomplish it and you were able to accomplish these things. A lot of time, some things that you practice at home, after a while you master it and you can apply it on a job. So you might take, for instance, you work in a particular industry. You might be a design engineer. You might be a design engineer and you start to take on odd jobs outside of your work, right? After a while, you couple your design with that aspect of the work that you learn with what you start to practice. Initially, the first project going to feel hard. It's going to be probably one of the most difficult things you do because all along you were just designing, right? Doing your calculation. But once you get over that initial fear, right, and initial start the task and accomplish the task, you feel accomplished and you feel like you can take on the next one tomorrow, right? So I encourage you, I always encourage students, talking with students, talking with even my colleagues who say, try the thing for yourself, right? I still have persons who call me when I leave this module and ask questions sometime and I say, listen, do that, do that, do that. Before coming to your class, I went to actually look on a job this morning. I have to leave the job site and leave two of my staff members on it, 2 members work with me on the job site, right, and to finish walk through and then sit down with them probably later tomorrow and have to come up with the costing, right? So I'm saying, and these persons are persons that went through this course that you're doing, right? So I'm talking about degree persons, but they will be working with persons with certification, right? So they are basically managing the work site. And I was saying to my wife this morning that, boy, I'm not even need for start, go up on the site now and look like a boss and just observe and go on rather than, but I don't know, I can't get out of the whole aspect of just working. I like use my hands, I like do something, accomplish it and see it and work, right, and have it work and you feel like you do something, right? But I just want to go there and just watch persons that do what they want to do and I point out one. And then enough time I go and work in the countries, person not even knows me are the boss, right? They will say other person and believe are the boss. They just see me a jump round, right? And I'm talking about my little side business when I talk about UTech, right? And them see me I jump round and I do whatever me I do and they on building top, they on tank top, or install circuit, install solar panel, install it. I just like doing it. No, if I isolate myself from this thing here, right? The technology will change and I'm not abreast of the technology and then the technology run past me and then probably I said, I stop get work coming down, keep up with the new technologies, right? So it's a critical part, guys, of the of your development stage. I know that some persons are already technical and they just want the qualification to go with it. So now you're getting the qualification and it's very difficult to beat you in a bid, you know. When you are bidding for work and you have the paper and you have the technical know-how, because remember when you are bidding for work, you need to show that you are capable of doing the work, and this is where your resume comes into place, or your previous job experiences, like different projects and so forth that you need to put on your term of reference policies and so forth, right? So very important, guys. All right, so moving on, we'll get a little sidetracked in here. All right, control methods for these. Obviously, this is in a corrosive environment, right? You can see that from the galvanized box, it starts to corrode, right? So they need to replace it with a All right, so we have another hazard we're showing here. So we're showing extension cards, right? This one is very, very typical in a residential setting. Even your work tool, right? Sometimes you have an extension card that you build after a period of time because of use. Then where you have your connection, it starts to damage, right? And your insulation start to come off. You need to re-terminate the cable because my extension, I build my extension. Every time I buy the little flimsy extension, they tend to burn up, right? When you run too much current through them. So I tend to buy flexible cord, which is that gray cable that you're looking at for the lower picture, and build my own extension, right? It work out much better. All right, show you some more damage cards. One, we have damage in the card through creases at door. This is very common in commercial and domestic settings, right? We'll show you the conductors and it, that look like conduit pulling off the wall, right? A lot of buildings, you have that in place, right? Where the and it typically occur when persons use a lot of trunking, right? Now, what persons don't realize is that when you are using, persons who have experience will tell you that when you are using PVC trunking with the adhesive at the back, when you place it on the wall, right? Remember the wall, most of the time it's going to be painted. Now, after a period of time, that PVC adhesive will pull the paint from the wall, right? And then it starts to hang down. Now, seasoned electrical worker or somebody that would have seen it done before would tend to use fixing screws, probably every 3 feet to hold the trunking in place, right? And this will prevent it in the future to come off the wall, right, and then start looking untidy, right? So anytime, and it's even easier in today's society because they have these concrete screw, the blue screw. You just buy the proper bit, buy the size screw, buy the bit, drill the hole, screw in the screw, and that's it. You don't have to do any plug-in with no wall plug. You don't have to shape no board and plug the hole and then screw in any screw. You just buy the concrete screw. Quick and easy. All right? One thing you need to know though, when you go to the hardware, when you buy the size screw, you need to ask them for the bit. If you don't know, ask them for the bit. Most of the time, the bit is one size less than the screw, right? Because it needs to hold tight. So for instance, if you are buying a 3/16 screw, which is a cross-sectional area, you need to buy a 5/32 bit, right? So you go one size lower with the bit, right? So you need to remember that. So when you're buying that's no side information when you're doing your projects. All right, grounding. A lot of us are guilty of this when we buy our power tool and it comes with a ground pin, and most of the time persons tend to remove the ground pin because they want to plug it into a 2-sprung socket outlet, right? So people, class, students, if you don't have any ground, right, most of the time the breaker will not trip, right? You need your ground or your earth for your high current to flow so that your breakers can trip. All right, guys, you need the ground in the installation. So that is basically one of the most important conductor in an installation. When I'm teaching electrical installation, I always tell students that's it's even more important than anything else in the installation. Without your ground, that is one of the main things the government GEI will check to ensure that your ground resistance is okay, right? Because without your ground, your earth, your breakers will not trip. You will have a circulating current, the wires will overheat, and then they will catch fire. They'll start to burn, and then you will have an electrical fire, right? Which will lead into bigger fire and house burning down and thing, right? All right, so we show you the ground pin, persons remove it, and we did show that before, the broken extension cord. Ground pin, no, if that happens, you need to cut off that plug end, buy a plug end, a 3-prong plug, make back your connections so that you have your earth, right? So that's an unsafe situation when we're talking about portable tools. Batteries, when dealing with batteries, right? Batteries, again, DC, right? Some of the hazards when dealing with batteries, we talk about electric shock, we talk about burns and shrapnel from exploding batteries if you have a short circuit. So when we're talking about solar installation, guys, you have to be careful because the solar cables that they use to connect the batteries are cross-sectional areas are large, right? So they will not burn out so easily. They'll tend to want to explode the battery, right? The battery will start to swell, right? For persons who say I will swell battery, yeah, it starts to swell and beyond a certain point, then it will burst. You'll have battery acid, right, and shrapnels flying. Chemical burns from electrolyte, right? So you need to wear your proper gloves when you are probably servicing your batteries. But today we have a lot of maintenance-free battery, right? So we don't have to talk about servicing and spill. The only way we need to talk about spill if the battery bursts, right? Then you will have spill. All right. We talk about physical injury from lifting or handling the batteries. They are heavy, right? Or from fire from overheating of electrical components, right? So when using DC power, so for instance, you're building a control circuit and it operates on DC voltage, then if your relays are not properly sized and your wires are not properly sized, then we run the risk of overheating equipment or components, and then which will lead to fire, right? So you need, especially when we're talking about battery banks, right? Because we're talking about probably these are the type circuits that will cause damage, right? 440 volts array and electrical classification, right? So we are at hazard classification in our lesson. So we talk about the classification our lesson in this category, right? 60 Hertz cycles and 50 Hertz cycle, DC, capacitors, batteries, all right, RF signals, inductors, photovoltaic systems, right? I would say all classes should be considered when identifying the hazards associated with any piece of electrical equipment. All right. Workers, right? Classification. Workers shall have thorough understanding of the equipment, right? This is where the training come into place. They are analyzing for hazards, consulting manuals and schematics, speaking with factory service representatives and electrical SMEs, right? No, it's very important that you do your research, people. Your research might be just talking to somebody that has used it before you. It can be consulting the suppliers, right? A lot of them will buy equipment for facility. We get why do we need to consult our suppliers? In particular, because Jamaica, in our situation, is a developing country. A lot of time when we buy a piece of equipment, we have to do some amount of modification, even though it's new, right? But not because remember these equipment are designed to work in probably a different environment, a different climate, right? And hence we need to do a lot of modifications locally, right? And we need to talk to the suppliers. Now a unique product to a particular supplier, right? All right, some guidelines on use of the hazard classification charts are provided below. They are general and there may be exception to each one, right? Classification 1X, right? Which is basically 50 to 60 Hertz cycles, or batteries which are classified as 4X. Thus, all equipment starts with one of these classifications. Small appliance, right? So we say they fall in the category of portable laboratory equipment, hand tools, appliance, and they will fall in the class 1.2 category, right? In general, these equipment are classified as medium or low voltage equipment from 110 to 240 volts, right? So these are our regular portable hand tool, which will carry a class 1.2, right? While our larger facility equipment, right, and lab equipment that is up to 440 will have a class 1.3, right? If it is a large motor or consume significant power, it may be a class 1.3 also, right? So we are saying that larger facilities that uses up to 480 volts is classified as class 1.3 hazard, right? So like at our power lab at UTech, we're using 400 and odd volts, then it's classified as a class 3, a 1.3 hazard, right? DC power, right, is classified as either 2, right, and for capacitance it is 3, right? So all UPS have hazard class in the 4x region as well as the 1x region, right? Since they usually are tied into facility power, meaning that a UPS will take the classification based on the voltage level present in a facility. So if it's a facility that have lab equipment like at school, right, UTech, then up to X voltages, then we talk about class 2. It might be a class 3 voltage, right, depending on the type of system that is installed. Now, the different classes carry different color codes. So a lot of time you might see these tags on electrical equipment, right, or tools, I don't know what the color mean. So these are what the color means. So you have your light blue and your deep blue, right, or some persons will call it navy blue, right, and you have the sky blue, which is the light blue. So we are saying that these are actually decision points, while the royal blue is really class X, right, or class 0, which indicates that you can have engineering or administrative controls are needed. So you can't just put up administrative and leave it, you have to put engineering. So for instance, in the workshop at UTech, where you have your lathes, the lathes have a guard, and at the same time you are unable to stand behind the lathe. So even though it have a guard, there's a safety sign there to say do not stand behind the lathe, right? So you have administrative control and you have engineering control. For your green, which is a class 1, right, indicates little to no hazard, right? So no engineering control or administrative controls are needed. You just need to follow the proper procedure. Now for yellow, it indicates, you realize that it's following the warning signs, the color of the signs. So injuries indicates injury or death. So the yellow is warning that danger is imminent, right? So it's a class X2, right? And then it's denoted by a yellow symbol, right? Engineering controls are necessary, right, for operation. Example, listing of our equipment approval, and administrative controls are also necessary in the class X2, right? So both engineering control and administrative control. For red, and then you have the maroon, right? It is a red is their typical prohibition color, right? Your maroon is just an intensification of the red, right? So the class X3 indicates injury or death from proximity. So you being near to your high voltage line, right, without the proper gear, can cause death, right? Shock, contact burn, or arc flash burns, right? Both engineering and administrative control is necessary.
What you refer to as the administrative control?
Signs. Anything that have to do with paperwork, whether you put up a sign.
I thought so, no, but I just wanted to.
Yeah, man, I said that before. So the engineering is really, it can be a policy, you know, it don't must necessarily be something like a sign over the machine. It can be a policy statement at the door or the entrance. That is also an admin control, right? But the engineering control is where you put the things in place.
Yeah, I thought, as I said, I thought so too, but I just
Okay.
wanted to make sure you and I were on the same page.
Okay, yeah, man. All right, and maroon is just as I said, intensification, right, of the red. So both engineering and administrative control are significantly needed, right? And the gray, right, takes the use of outside electrical safety control as a primary hazard is chemical explosion, right? So the gray is really beyond electrical means, and you need to have no chemical protection against chemical explosion. Like, for instance, transformer, that oil field transformers and so forth, these have both a chemical aspect to it and the electrical aspect to it. All right, as our controls, talk about this in much more detail, but another way to control hazard, these types of classification hazard is your GFCI. For persons who don't know, it's our ground fault circuit interrupters, right? You may find them in your household where you have like in your kitchen, right? You normally will find one in your kitchen. If you have a plug in your zone 3 in your bathroom, you might have a GFCI outlet, but our local regulation require us to use a GFI outlet as well as a GFI breaker, right? Now, the reason for this is that a lot of times when, because of the cost of the GFCI outlet, when the outlet goes bad, person tend to want to change it and put in a regular socket outlet because they are going to say, well, the regular outlet work just the same, right? No, if you remove it, then you will still have certain amount of protection from ground faults. Now, if it's not connected properly, it will not work properly, right? So you must ensure that your earthing is connected in the building, and you must ensure that the earthing for the GFCI breaker and outlet is properly connected, right? Without that, it will not trip on ground faults, right? Fuses and circuit breakers, right, are also used for overcurrent protection, right? So like when you have a short circuit, you have tend to have a lot of current flowing. So these will sometimes blow your fuse, depending on the type of fuse. It might be instantaneous or it might be a slow blow fuse, right, which will take a time to blow, right? So it might be a case that you know that you are going to have a lot spikes, so you don't have a fast action fuse because the spike is not as critical to your circuit, so you would tend to want to use a slow blow fuse, right? While the circuit breaker will trip on overcurrent, whether from overloading or from short circuit, right? All right, so this is our GFCI breaker, right? So it have a test button and it have a reset button, right? When
I
it
mean,
trips,
GFCI plug.
uh,
You said GFCI breaker, but that's a GFCI plug. I mean,
yeah, outlet, yes, sorry about that. GFCI plug, right? I guess we're getting weird now. GFCI plug, our socket outlet, right? So it have a test button and it have the reset button, right? So in the trip condition, I don't see a light on this one, but it should have a light to indicate that it is in the trip setting, right, where you need to go and reset it, right? It will either have, some of them will have a green and a red light, and the red light will indicate that it's tripped, while the green light will indicate that it is working properly, right? Some of them you might have the reset button as red, yes, and so on. But it all depends on the manufacturer. All of them work the same way, right? The manufacturer will have different fanciness to put on it, and you will pay for the plug being fancy, right? It also requires us to use a double insulated equipment for working on sites, right? When using power tools, you should be using a GFCI outlet, right? And it should be powered by low voltage. So most portable tools are within the region of 110 to 220 volts, right? You will not, most of the time, you will not find a portable tool beyond 220. Well, in some cases, 240 because they might bring the equipment from America or England, right? Which is slightly different in the, whether it be 415, 440 or 430, right? It depends on the region. All right, so this is what we are talking about, the double insulated tool. For portable, double insulation for portable tool, which is required for working when you are on construction sites in heavy duty industries. And this is why we talk about having quality tool to do the job, right? So as not to have any short circuit or defective tool. All right, I'll show you a broken down extension cord shown here, right, which is worn or probably stripped or probably squeezed again somewhere, or it might be under decks and it rips, right? But these should be addressed and repaired or removed and replaced, right? All right, we're talking about lockout and tag out. We mentioned it earlier, but this is how it is done in some cases. Right, so they use a small padlock and they use a tag, right? And the tag must indicate that the circuit is locked out and being worked on, right? So you need to apply locks to power source after de-energizing. You need to tag the activated controls, tag the energized equipment and circuits at all points where they can be energized. So most of the time, it can be energized on various points. You need to tag them, right? Tags must identify equipment or circuits being worked on, right? For instance, you might not be able to lock out the entire panel, but they also, you can also buy locks that are used to lock out individual breakers, right? There are specialized type of lockout devices that they can use to lock individual breakers in place. All right. Now, how do we prevent them using some regular everyday work means, right? Plan your work activities with others, plan to avoid falls, plan to lock out and tag out equipment, remove jewelry, very important for electrical persons, especially when we're working around live parts and rotating parts, right? Avoid wet conditions and overhead power lines, right? So we show you broken insulation, avoid wet condition. We have water here and we have broken insulation, right? And we have live conductor right there, right? So these are things that will pose hazards that we cannot see readily, right? So this is probably something that is in a hidden corner that is not easily seen unless probably somebody become electrocuted or get a shock or something, unfortunately, right? But we need to repair stuff like this. So actually, I'm showing you not to be a dummy, right? And be this person and stand in the water because it will cause you to become electrocuted, right? I don't say shock, you know, realize I don't use the word shock because when you become wet or moist, your body resistance goes down and the current passing through your body gets more, right, or increases. Again, typical work condition, person working with a saw, probably he's not an engineer or electrical person, so he don't realize that the connection that is shown there is almost in the water, can cause electric him to receive a shock or damage to the tool or burn up the tool, right? A lot of possibilities. All right, we went through these already. All right, this is the GFCI that I'm talking about with the red and the black terminal, and it have the indication lights where the arrow is, or below the arrow there, right? We will go through this in a bit more detail when we're looking at the device themselves, right? So we look at the circuit for the GFI breaker and how it operates. All right, we are saying that we went through this before, but just to iterate, train employees working with electrical equipment in safe work practices, de-energize electric equipment before inspecting or repair, right? So we are coming to the end of our lesson. We are just summarizing. Use cords, cables, electric tools that are in good repair, lockout, tag out, very important, recognition and procedures, use appropriate protective equipment, right? Very important. Don't play with your PPE, keep them in a safe place, right? Change them when they need to be changed. We know that safety shoes is a bit expensive, but they should be provided by your employers, right? Look first, right? What if you see somebody being electrocuted? Look first, very important. That's what we learn in first aid. Look first, assess the situation, but don't touch. Turn off the source of electricity if possible. If not, move the source away from you. If not, right, or move or from the affected person using a non-conducting object, right? And I said non-conducting object, and I said move. So don't kick the person, you might injure them. Don't lick the person with anything, right? If you don't see a safe way, right, try to make a safe way without injuring the persons further, right? Get emergency medical services, EMS. Try not to touch the burns, right? If qualified, start basic first aid and CPR as necessary until EMS arrives, right? And I put if qualified because if you are not first aid certified, right, please do not administer first aid. You might do it incorrectly and cause more harm than good to the persons, right? As technical persons, guys, I would encourage you to do a course in basic first aid, right? It's very useful. I think it runs for 3 years of certification, and then you have to recertify. I think my certification expired this year, right? So it's a case that you need to recertify it. Why? Because every now and then they have new procedures for doing things, right? So we don't want to be complacent. Now, safe electrical isolation. Always make sure that the supply is switched off, right? Which is your means of isolation, right? Which is regulated by the IEE 130-06-01, right? So that regulation speaks to a means of isolation that every electrical circuit must have a means of isolation, right? In order to deter anyone from reconnecting the supply, a danger electrician at work sign should be displayed on all isolation, right? How do you make safe isolation? We need an approved and certified testing instrument, right? It might be a voltage indicator as shown on your left, or a digital multimeter, which is shown on your right. And these must be GS38 compliant, right? What do I mean by GS38 compliant? Now, GS38 compliance means it must have a safe test lead. The safe test lead must have a barrier, So that is that little thing that you see on the end of the test lead so that your hand don't slip. If you have mice on, it will not slip onto the circuit that you are testing, right? It must incorporate a fuse. So if you go back and look on your meter test lead, on the lead itself, the part that you hold, you will see 10 amp.
Afternoon, sir.
Yes, afternoon. You're just coming to class?
Oh, sir, I was here Wednesday, but the tutorial. I'm just coming to the tutorial.
Oh, we're not doing a tutorial today, but we're just finishing up some notes. So tutorial is really next week.
Okay, no
Yeah.
problem.
So you're not missing anything because you will go through this. I don't think we have reached here in your class, right? All right, so if you were to look on your test lead for your instrument, for persons who have their personal multimeters, when you look on your test lead, you will recognize that you have a 10 amp fuse inside the test lead. However, because of how the test lead is designed, that fuse is a slow blow fuse, right? So it don't blow easily. No, however, when a test lead tend to blow the fuse, you're unable then to change the fuse in a test lead because it's made as part of the lead. You need to discard the lead and you need to buy a lead, right? So unlike the meter, you can just go and buy a lead and it will fit a standard multimeter, right? So they have standard leads of different quality that you can buy. You have more expensive leads, you have less expensive leads, right? And going on further, right? So this is a breakdown, a cutaway view of your GS38 compliance test lead, right? So I'll show you the cutaway of the fuse. You have your standard shrouded ends, right? You have your barriers, right? You have your tip, right? You have this, and not all test lead will have insulation up to the tip, right? Some have it from the barrier down, you'll have conductor being exposed, right? Now, there are certain procedures that you must follow, but we don't follow it in Jamaica, we don't follow it in a lot of countries, but I must teach it to you because this is how it starts, right? The Electricity at Work regulation recommends that you first connect the test device to the supply, right, to a known supply, right, that you want to isolate, test the device, right, again, on the mains, that is what, like say a panel, you go to your panel, make sure your device will work, identify the circuit that you need to isolate, test back isolate the circuit, test that the circuit is dead, and then you go and then retest your meter on the mains again, right? But a lot of time we just go and test the circuit, isolate the circuit, test again and it dead, and that's it. But the proper testing procedure says you are to retest the device, right? Why? The device can become defective while you're testing. It can be a case that the voltage leaked the device. It can be a case that the device battery is low, right? The good thing about it, a lot of these new multimeters, unlike the analog ones before, this was developed for analog meters, right? Digital meters have a battery display to indicate to you that the battery is getting low, so we don't have that occurring much in today's society. Now, finally, you need to secure, that is when you put your small padlock and put up your safety signs in place. And that will take us to the end of our lesson. All right, guys, so next week now, just before you go, next week we'll complete, we'll be looking at safety at work again, completing safety at work. And then I will issue a tutorial paper to you, right? We will possibly not go through the tutorial paper next week because I need to give you time after completing safety to look to go through the tutorial paper so that we can discuss it for the next class, right? So I don't want to discuss something that you haven't gone through yet. All right, guys?
Yes, sir.
All right, so
Okay, sir.
next week, remember, I'm going to send you the invitation later for the Google Classroom. This slide will be up in the Google Classroom, right? It's actually up already. I just want me to send you the invitation. What I need to do is also post it in your Moodle for persons who are not going to use the Google Classroom. All right? So next week, read back through your slide, go back through your